Mm-hmm. Look how big I am. Ooh.
It's full of people.
I know. Some more and more people want to just view it later, you know, when it's more convenient for them, I guess. That's fine with me. Doesn't make me any difference. Okay. Yeah, I think it's working. That's good. There. I think. Yep. That's good. This thing's not supposed to be here. I'm recording. You are sharing the screen, recording. Everything's good. Let's see. Big crowd, big crowd. Okay, we did. Hey, good morning, everybody. Today is Thursday, February 25th, 2021. It is 11 o'clock. And you guys are my Tuesday, Thursday section of biology 1160, section 2. Okay. And we met Tuesday, and I'm thinking Tuesday we were, I think we finished the hands, didn't we? We finished this, the cranial extremities, right? And I remember going through the hands. I tell you about Henry caught 10 turtles plus 3 little snakes, and then the finger bones. And I think that was it. And then we got to here. Is that right? Sounds about right. I think. Right, Gurley Green? You would know, wouldn't you? Is that correct? Yeah, I have like 2 students in here. I call on you, but you're way up there in the stratosphere. Okay. All right. So basically, we're going to just do the same thing to the lower extremities and finish this up. Then we'll be able to start muscles, and we'll get close to finishing that, and then we'll talk about your tests, which is next week is midterms week, so you have your test next week, and I think we could comfortably have it on Thursday of next week, but let's talk about it at the end of class. And anyway, let's finish this. The caudal extremities. 62 bones, right? Then what I have? Let me find my laser just in case I need it. All right. And it begins with the girdles. Right? Remember, there's a pectoral girdle. Of course, there's a pelvic girdle. And remember, the pectoral girdle only had 2 bones. The pelvic girdle, this is another mammalian thing. There's only 1 bone, 1 pair of coxal bones, or known as the os coxa or ossa coxae would be plural. Okay, which means hip bone. And here you can see the axial skeleton, which is basically just the sacrum. And these bones, the hip bones, articulate via the sacroiliac joint. That's what you call it, this joint right here that is where it unites. It's where you're looking at where axial and appendicular come together, okay? And like I said, there's just 1 pair of bones. And again, this is a mammalian thing. Only mammals have just a pair of bones. Just like only in mammals, there's only 2 bones in the pectoral girdle. And so it's true that there's only 1 pair of coxal bones forming the pelvic girdle in mammals. There would be 2 or more, usually 3, in non-mammalian vertebrate skeletons, okay? Now, why is that? Well, if you look carefully at one of the coxal bones, like I have here, you'll see that it's actually 3 bones in 1. It's from the union of 3 separate pelvic girdle bones fusing around the head of the femur. So right here, it's your hip socket, which is called the acetabulum. That's where the head of the femur goes. And in non-mammals, these bones are separate. But in mammals, they kind of fuse around where the femur is going to attach and form 1 bone. And again, you see this in the vertebrate skeleton. Wherever you want to fortify an area, make it stronger, you reduce the number of bones. And this is a classic example right here. Instead of having 3 little bones, you have 1 big heavy duty bone. Because you think about what's going on here, your inferior appendages or your posterior appendages, if you're a quadruped, that's where all the power for moving the tetrapod comes from. So your legs are much bigger than your arms. And all animals it's the exact same way. That there's a lot more force back there. And so to fortify that and to transfer all that force into the axis, you really have to make this girdle bone heavy duty. And that's what you have here. In like I said, non-mammals, it's not so much like that. The mammals are like the pinnacle of terrestrial existence, the pinnacle of tetrapod evolution. And so they have a really modified skeleton. But, humans, pelvic girdle, no different than a horse, no different than a dog. They all have just like 1 pair of bones. But we identify the 3 bones, the 3 portions of the coxal bone based on the bones that come together. For example, It's like three. There's 1, 2, 3. It's like one superior bone and two inferior bones. The superior bone, that's your, what you just call your superior hip or your hip bone. That's the ilium, the I-L-I-U-M. Now, in anatomy, there's two words, ilium and ilium. There's I-L-I-U-M, which is the hip bone, and there's I-L-E-U-M, which is a part of your small intestine. So just kind of keep that in mind. So if you're like Googling ilium, then there's a difference. Because if you speak into like your phone, it might spell it wrong. And then you're looking at the intestines, why? But anyway, I-L-I-U-M is your big hip bone, like where you got your love handles. Then the two inferior bones, there's an inferior anterior bone and inferior posterior bone. The inferior anterior bone is the pubis. That's the one that's down, but in the front, the purple one here, forming the pubic symphysis. Symphysis is a type of joint or an articulation, and it's slightly movable. It'll move a little bit. It's where the left pubis articulates with the right pubis. It comes in the front, in the pubic region, right? That's the only place the two girdle bones articulate, right there. That's the only place they come together, right there, the pubic symphysis. And then finally, the ischium. The ischium is the inferior posterior portion, the green one in the back. That's your butt bone. That's what you're sitting on. If you're sitting down right now, you're sitting on your butt bone or your ischium. Noteworthy structure is the ischial tuberosity. It's the big kind of, that's another, I threw this in here so I could give you this term tuberosity. Remember, there's all these bone terms, osteological verbiage, and a tuberosity is another one. You got tubercles, tuberosities, trochanters, and all these things, foramina, fossae, whatever. Well, this is another one. And a tuberosity, again, is a enlarged structure on a bone for something. And it's to accommodate something. In this case, the ischial tuberosity is where many of your gluteal bones, your gluteal muscles, your butt muscles articulate there. And so, I don't know, it's just noteworthy. It's a structure that you'll see on there. And we'll look at more detail of this in lab. So anyway, that's your os coxa, or your coxal bone, okay? And then all three of them kind of come together right here in the hip socket. The hip socket itself is called the acetabulum. You see acetabulum, which means literally wine cup. I guess it kind of looks like a chalice. If you look at a hip bone in person, it's a nice, smooth, scooped out structure. And I guess to early anatomists, they go, hey, we can drink some wine out of that or something, use it for something. I guess, I don't know. That's what acetabulum means wine cup. And that's it for your girdle, lickety split, huh? Then you move on to the appendages. And the legs and the arms are basically, they develop the exact same way. They develop into the three segments, basically. Well, the initial segment that attaches to the girdle is contains an unpaired bone, and on that paired bones and so forth. Well, the initial segment is your thigh, your upper leg, and likewise, like your arm. Your upper arm, there's only one bone, the humerus. Well, in your thigh, there's only one bone, the femur. Now, all this detail associated with the femur, I'm saving that for lab. I just want you to know where it is and what it's called, all right, and what's associated with it, okay? Number 3, the kneecap. The kneecap, that's your patella, all right? And you don't really have, well, you don't have a elbow equivalent to this, because remember, the kneecap or the patella is a sesamoid bone, and it's not really a part of the skeleton, but it is. We include it in the skeleton. Of the 206 bones of the body, your right and left kneecaps count is 2. Okay, so without these, you would only have 204 bones in your body. But again, you can see it here. It's a true sesamoid bone suspended in a tendon. So where your quadricep muscles, your anterior thigh muscles come together, form this tendon, and then it passes over the knee joint, all right, and then articulates right here on this knot on your tibia. This is your tibia down here, and there's your fibula. The tibia is called the tibial tuberosity. That's for the anchoring of the patellar tendon. And on this side of the knee, they actually call this called the quadriceps tendon. The quadriceps tendon, patellar tendon, same thing. But like in the middle is your patella, or your kneecap. But there it is. Now, beyond the knee, you got the lower leg, or in biology, we call this segment of the posterior appendage the shank. That's kind of a weird sounding word, shank or lower leg. It's the same thing. But like it's the leg's equivalent to the forearm, right? In the sense that there's 2 bones in this segment, and the 2 bones are the tibia and fibula. Not tibula, don't say that, tibula, no, it's tibia and fibula. Which one's which? Well, the tibia is the big one. It's medial, the big medial shin bone. And this view that you're looking at right here is an anterior view of the right shank, the right lower leg. Okay, so because this would be, the midline would be right here. This would be the right leg. And of course, the left leg would be over here. This is the tibia. And then the fibula, F for fibula, F for fine. It's the fine lateral bone, a little thin little bone on the side. Here I say that it's thin and it's weak. Thin and weak because it doesn't really do too much as far as supporting the body. You see this in the vertebrate skeleton, particularly in tetrapods. I mean, bipeds. You got bipeds and quadrupeds, quadrupedal and bipedal, things that walk on 2 legs versus things that walk on 4 legs. Things that walk on 2 legs, you've got much more force coming down on the shank opposed to something walking on 4 legs, right? If you're walking on 4 legs, half of your body's mass is distributed on the forelimbs, right? Well, if you're standing upright, all that mass is being directed down just your hind legs, all right? And again, your body doesn't like to use a whole bunch of bones where you got extra stress on it. And so in bipedal things, you'll see a reduction in the number of skeletal elements in the shank, all right? So in other words, in the lower leg. And so most of the weight is directed down the tibia, and the fibula just kind of becomes vestigial, all right? And of course, humans, we walk on 2 legs, and that's where you got a big old heavy-duty tibia and a little wimpy little fibula. And you see the same thing in birds, like a chicken. If you'd eaten a drumstick from Popeyes, what are you eating when you're eating fried chicken from Popeyes or Church's or whatever? No. Does anybody eat any other kind of chicken? I wouldn't see why you would if you have Popeyes. I'm a big Popeyes fan. Anyway, the drumstick, this is what you're eating. When you're eating a drumstick, you're eating a shank. But don't go to Popeyes and order some shanks. They won't know what you're talking about. Give me some shanks, some wings and some shanks. Now, that's the shank. When you're eating the calf musculature of the chicken. Now I'm taking all the romance out of it. And you go, "Ugh, I'm not going to eat chicken anymore." Anyway, that's what you're eating. You're eating the calf musculature. And then you get down to the bone. That's the tibia. Have you ever noticed? And sometimes it's not even there. There's a little thin little bone, little thing. That's its fibula. The tibia is, pretty heavy duty. Because birds, particularly chickens, they walk on their legs. They don't use their forelimbs for distributing its mass and battling gravity. They use it for flight. So you see that. So anyway, here's your big heavy duty tibia. And then beyond the tibia and the fibula is your foot, the pes. Remember, the hand is the manus, the foot is the pes, P-E-S. And likewise, your foot is divided into three regions: a tarsus, metatarsus, and your inferior digits are your toes. Of course, bones of the tarsus are collectively called tarsal bones, and bones of the metatarsus are called metatarsal bones. And in the human foot, there are 7 tarsal bones, 5 metatarsals, and 14 phalanges. Almost exactly like the hand, but not quite. You have one less tarsal bone opposed to carpal bones. So you have 8 carpal bones, 7 tarsal bones. And what are they? Well, I tell you, there's 7 per foot. I don't really have a little jingle for it because they're actually pretty easy when you think about it. Some students have tried to come up with some little mnemonics for the tarsal bones, but I don't know, they're kind of lame because they're pretty. There's fewer, I guess, one less, and they're pretty distinct looking. Like, for example, the first one I have listed here, the calcaneus. That's your heel bone. That's the real big one right there. This is what you're looking at here, is a superior view of the right foot. So you're looking down at your right foot, and that's your big heel bone, and there's your calf musculature forms a tendon and inserts right here. And of course, see the tuberosity of the calcaneus. That's to accommodate the calcaneal tendon, or we call it the Achilles tendon. I told you about Achilles. We talk about Achilles. If you study or read mythology or enjoy those stories, you learn about Achilles and his tendon, or his ankle, really. Anyway, but that's it. It's big old heel bone right there, a calcaneus. And then next to it is the talus. You have in parentheses, supports the tibia. You see this kind of white surface? That's the articular cartilage on the tibia. So it's the trochlear surface of the talus. And so I think the 2 T's go together, talus and tibia, because the tibia, the big shin bone, it comes in direct contact with the talus. That's the only bone it articulates with. So the tibia and talus go together, and that's really your ankle joint right there. None of the other bones are actually incorporated. They're all just kind of part of the sole of the foot. But there's your talus right there. And then, in front of the talus is the navicular, all right? You can see this is all talus right here, and this kind of squished one right there, that's your navicular. And then lateral to it is the cuboid. And cuboid, not cuboidal, don't say that, cuboid, just cuboid, because it's, I guess, shaped like a cube. And if you look carefully at the cuboid, it's kind of like your foot's equivalent to the hamate. Remember I told you about the hamate? You had 4 distal carpal bones, and one of those distal carpal bones supports 2 metacarpals, right? Well, here you also have 4 distal tarsal bones, and the cuboid is the only one that supports 2 metatarsals. This is the 5th metatarsal and the 4th metatarsal. Notice that they both articulate with the cuboid. All other metatarsals 3, 2, and 1 articulate with their own distal tarsal bone, okay? And you're gonna like this even more. These 3, they're collectively called the cuneiforms. And this first cuneiform here, it articulates with the first metatarsal, which is named after the first digit, right? Say 1, 1, 1. This is all like your big toe is your first digit. You know, you don't have like index toes or you remember your hullux, and your pullux. Well, your big toe. This little piggy went to market. That's that one. This little piggy stayed home. That's number 2. This little piggy had roast beef. That's number 3. And this little piggy had none. That's number 4. And this little piggy went wee, wee, wee all the way home. That's number 5. And so this is metatarsal number 1, 2, 3, 4, and 5. Okay, these first 3 cuneiforms are named after the digits. This is cuneiform 1, cuneiform 2, and cuneiform 3. And then this one is 2 in 1, right? So it's just called the cuboid. So first, second, third cuneiform plus the cuboid collectively make the distal tarsal bones. Okay, now, having said that, look how they label these. Medial, intermediate, and lateral cuneiform. That's fine. If you want to call them that's okay. This is the because if you look, this is the right foot. This is the midline of the 3. This one would be most medial. Number 1 is the same thing as the medial cuneiform. This one's in the middle, so it's intermediate. Of the 3, this is the most lateral one. So some authors will call it the lateral cuneiform. So the number 3 cuneiform and lateral cuneiform is the same thing. I don't like using that verbiage because when you say lateral, to me anyway, you think lateral like on the side, but it's like they're in the middle of your foot. So of the 3, yeah, sure, it's most lateral, but I don't know, I just don't like it. But if you want to call this one right here the lateral cuneiform, more power to you. I call it the first, second, third. And I know what you're saying. Well, how's it going to be on the test? The way Mr. Williams likes it. That's how I put it on the test. Use my verbiage, first, second, third. So anyway, and then the cuneiform. And of course, all 3 of these are supported by the navicular. See, the navicular supports all 3 cuneiforms, and the cuboid just kind of, it articulates with the calcaneus. So there you go. There's your foot. At the bulk of it. The rest are the metatarsals and phalanges, and it's just like the, I'm going the wrong way there. Just like the hand. So that's where you had metacarpals, now you have metatarsals, 1, 2, 3, 4, 5. And the phalanges the exact same way. You have 14 phalanges, just like you have 14 finger bones, you have 14 toe bones. The first digit only has 2, a proximal and distal phalanx, and then all other digits, 2 through 5, have a proximal, middle, and distal phalanx. And of course, you distinguish between them by adding a number, like, you know, proximal phalanx 2, middle phalanx 3, distal phalanx 5, whatever. It just depends on which one you're talking about. And that's it. The end. La fin. Okay. So we're done with the bones and the skeleton, and what do we have left? Just the muscles, right? And then we'll be ready for our test. So let's open the bone stuff. Let's see, where is it? I have to browse. There it is, right there, muscular system. And then after this, you'll be ready to go. Now this is not a lot of slides. All right, let me show you. Not a lot of slides, but I got a lot of info packed into these, 18 slides? I've got these infamous Mr. Williams tables that I put together. You know, you can pack a lot of information into a table, so don't let this fool you. You know, I want you to learn all this stuff really well because I can ask a lot of questions from it. So let's talk about the muscular system. All right, and we go. I think I'm going to have to adjust my display here for you guys at home. That looks good. I don't know what this is all about. Okay. This is new. I never had this thing. It didn't used to show up at home on the recording, but now it does. I don't know. Things are happening weird now. So I'm going the wrong way. There we go. My first slide, muscular system. The structural and functional organization of muscles. And so remember, the muscular system is what you're looking at. This diagram is the muscular system. Now you have three different types of muscle, right? You have cardiac muscle, smooth muscle, and skeletal muscle. But this body system that we're talking about is just skeletal muscle. Okay, so you wouldn't really talk about smooth muscle and cardiac muscle when you're talking about myology. Because we're talking about myology. You're talking about the organs in this body system, and these organs are all skeletal muscles. Like bones. You had 206 bones. You have about 656 named muscles, organs in this system. And so, oh my gosh, you're going to go through and point out every one of these muscles? No, I'd be here all freaking semester trying to do that. So, what are we going to do? Well, I'm going to tell you about nomenclature and give you a background on like a general anatomy of the organ, like I did for the bone. And then from there, we're going to go on talk about nomenclature, okay? So it's not going to be that bad. So elements of the skeletal muscle include, it's like this, how they're built, the structure of them. All as organs, the skeletal muscles are composed of the following elements. First, you have fasciculi. They're built out of fascicles. In anatomy, you'll see this word again in other organs and structures. Fascicles or fascicula, that's I guess the Latin form, or bundles of something, fascicles, groups, okay? And so in muscles, fascicles are bundles of muscle fibers, okay? Now, when you're talking about muscles and you use the word fiber, that's just kind of like a general term, fiber, this kind of fiber, that kind of fiber. Remember, we had collagen fibers, and there's cytoskeletal elements that are considered fibers. It doesn't really, define something particular. It's kind of arbitrary, but when you're talking about muscle, and the word fiber is a cell, because the cells of muscles are huge. And they're long and cylindrical, and they can look like fibers. They're very fibrous-like, or filamentous. How about that? That's a cool word, filamentous. So muscle fibers grouped together are called fascicles. And of course, what holds them together, you're going to have these connective tissue wrappings that bundle everything together. Okay, so muscles have fasciculi, which are groups of fascicles. Fasciculi, which are groups of fibers, all right? You also have a capillary network. Each muscle is supplied with at least one artery and one or more veins. That's typical of just about any organ. You're going to have more veins than arteries. The arteries are delivering oxygenated blood usually to the organ, and the veins are usually draining the capillaries, okay? And then speaking of the capillaries within muscles, they tend to be coiled to allow for stretch, because the muscles, remember, they move, they get bigger and smaller and so on and so forth. So the capillaries have to accommodate for that. And of course, in turn, functionally, what the capillaries do is what capillaries do. They provide oxygen and nutrients to the muscle, and at the same time, as when they're draining blood away, they eliminate waste products. That's pretty standard, okay? Third thing that you have are the fiber connective supporting tissues. those actual connective tissue wrappings that compartmentalize the muscle. It's collagenous and elastic fibers, which act as binding harnesses around the muscle. It provides support and reinforcement. It gives the muscle elastic properties, remember, like stretch and recoil. It also allows for a uniform contraction. So the whole thing can contract as a unit, all right? And of course, the connective tissue fibers themselves also aid in anchoring structures to the surface of the muscle itself, like blood vessels and nerves and whatever, all right? It could be other muscles and be skin and so forth. So we'll look at all that. All right. The organization of muscles. The fibroconnective supporting tissues package the muscles into 3 different tunics. All right, you see this word tunic. You have a tunic. Here I have in parentheses coats, or a cloak, a tunic. This is like an old term, a tunic. I'm trying to think the only person or people that I can imagine that wear tunics now are priests. I'll give you a little background on anatomical terminology. Back in the day, when you were educated, everybody was taught in Latin, all right, and usually the universities and the institutions of learning and the Catholic Church were like one and the same, and so there's a lot of crossover from the Catholic Church into scientific terminology, particularly biology and anatomy, and so you see like some connections here. I don't know if you know much about the outfit. I don't want to call it a costume that a priest wears, like like a cape, or I don't know what you call the gowns that they wear. Well, they call them tunics, and they're dressed. A priest is dressed in layers. For you non-Catholics that don't know this or whatever, but they're dressed in layers, and the Catholic Church is very, very symbolic and a lot of symbolism and history and tradition and so on and so forth. Well, there's a meaning behind every single thing in the Catholic Church and everything the priest does. And the priests are dressed in layers, and each layer is called a tunic, okay? And each tunic means something, all right? And look at this too. See the number 3? And you'll pick up on this in anatomy, if we haven't talked about this already, that there's always 3. 3 this, 3 that, 3, 3, 3. You know, is that a natural thing, naturally occurring thing in nature, that nature always makes 3, like three layers, 3 types, 3 categories? No, that's all completely made up. That's all human. That's a human thing. We look at things, it makes it easier to help categorize and memorize things in groups of 3. Somebody did a study on this, you know, why we always put things in 3s. Like your Social Security is 3 numbers, your telephone number is in 3 numbers, and this is in 3 groups of 3, 3, 3. And anatomy, you know, oh well, there's 3 parts of the muscle and 3 parts of this and 3 parts. So you'll see it over and over throughout the course. But here, you look at the muscle, it looks like it has, you know, 3 layers. And the early Latin anatomist, I guess Romans, said, hey, those are like cloaks or tunics, I guess to say, that the priest wears. And they all have a name, of course, and I'm going to share the names with you. The first tunic, the first layer, so the endomysium. And these are all fibrous connective tissue, okay, layers. Endo means like, inside, deep layer. It's a very thin tunic of connective tissue surrounding each fiber. And it's arranged the fibers within fasciculi. And so I can't really point to this stupid thing popping up. But you can see a section through the muscle. And then you see these little bundles, little groups. Each little group is a fascicle, okay? And the muscle cells in the fascicle are wrapped in endomysium, okay? You see that? Then there's perimysium, a slightly thicker tunic of connective tissue that's around and between the fasciculi. So this kind of yellow material on the outside of the fascicles. That's perimysium. So you kind of, between the fascicles, perimysium, around the actual fibers, endomysium. And then finally, wrapping the whole thing up is epimysium. You have epimysium, the thickest superficial tunic, which are right on the outside right here, enveloping the entire muscle. And it in turn, since it's on the outside of the muscle, aids in muscle attachment. We'll talk about different types of muscle attachment. It'll actually segue to some kind of muscle attaching structure, which is going to be made out of a fibrous connective tissue element as well. Okay, so there you are. There's your three tunics. And we'll see tunics or cloaks like this and other things as well. Anyway, so on to the connective tissue attachments of the muscle. The connective tissue for muscle attachment is classified as dense, regular connective tissue. Remember that? Remember when we were studying histology, we had dense regular, dense irregular, and elastic and all that. Well, but really the only place that we would see dense, regular connective tissue was forming tendons and tendon-like things, and that's true. And so there you have it. The tendons, or the dense regular connective tissue, this connective tissue extends from the epimysium to the dense irregular connective tissue covering some kind of other structure, okay? And so the dense irregular connective tissue, the epimysium that's on the outside of the muscle wrapping the whole thing is dense irregular connective tissue. And it's kind of like the dense irregular fibers straighten out to form a tendon. How about that? Because they're regular, they become regular, and those collagen fibers eventually blend with the dense irregular connective tissue on some other substrate. What? Well, it depends what it's attaching to. If it's attaching to bone, then you have dense irregular forming dense regular, and then dense regular to dense irregular on the bone. And the dense irregular on the bone is called periosteum. Okay, it's the same thing. Periosteum is the same thing as a perichondrium if it's on a cartilage, or a tendon's going to attach to other muscles, and if they attach to another muscle, they're going to attach to the epimysium. So you think about it, what I'm trying to tell you here is periosteum, epimysium, perichondrium, all the same thing. It's all dense, irregular connective tissue that's covering either a bone or a cartilage or muscle, and that's what the dense, regular connective tissue kind of blends with, because it's all collagen fibers. The only difference is they're regularly range or irregular range. The only place they're regularly range is between the muscle and the substrate. How about that? Now, let me give you some examples of the connective tissue attachments, because not everything's a tendon, okay? You have attachment structures called fascia. Fascia is basically where the muscle makes a direct connection to the substrate. It's basically there's no tendon. It's just epimysium directly attached to something, all right? But the key word here is direct. You have one that are direct. The other two examples are indirect. So this is the key word here, indirect connection. So what is a tendon? A tendon is where a muscle makes an indirect connection with a thick cord or band of dense regular connective tissue. And that's what you see right here. That's normally what you think about when you're thinking of how muscles attach to some kind of substrate. It's usually by way of a tendon. And the tendon is just pure collagen fibers, dense regular connective tissue. Okay. If it doesn't use a tendon, it's just fascia. All right. Now, there's one kind of third, it's kind of like a special kind of tendon, I guess you can say. It's called an aponeurosis, or aponeuroses would be plural. Again, it's where it makes an indirect connection, but rather than using a thick cord or a band of dense regular connective tissue, an aponeurosis forms a large, thin sheet of dense regular connective tissue, like a huge, big, thin tendon, but we call it an aponeurosis to distinguish it from a tight cord. Usually you can see through them, they're so thin, but it's just all just pure collagen fibers. I point out one right here, the Galea aponeurotica, which just means the aponeurosis on top of the head. And then there's another one covering your rectus abdominal muscles on your abdomen, and there's a few in the body, but not as common as just regular old tendons, or again, where you don't really have tendons. You can see some smaller muscles that just kind of connect to each other. There's not really tendon there. There's just kind of white connective tissue. That would just be fascia, okay? So there you go. There's that. Now, about attachment points of muscles, and basically how muscles work. Each muscle has two attachment points. Of course, we identify those. All muscles have an origin. The origin of a muscle is the fixed, more stationary end of the muscle. In other words, like the end of the muscle that doesn't move, okay? When I think of the origin of a muscle, I always think of like the anchor man on a tug of war team. You know, a tug of war, you're pulling on a rope, and the team, the object of the game, I guess you call tug of war a game, huh? Is you just want to pull. You pull in one direction, and you pull towards the anchor man. The anchor guy is usually the big guy that kind of hangs and makes sure that it doesn't move. And so your origin is you're always pulling towards the anchor man. And so there you go. That's the end that doesn't move. All right. The opposite end would be your opposing team, right? That's the end that you want to move. You want to pull them into the, what is it? Usually like a pool of water or something when they lose or whatever. Or maybe it's just a line in the sand or something. But anyway, the opposite end of the muscle is the insertion. So all muscles have an origin and an insertion. The insertion is the movable end of the muscle. This is what elicits the motion at the joint. And so it's usually on the opposite side of a joint, all right, and it's moving bones, okay? And so that's how muscles work. They're always pulled towards the origin, and that's it. They never push, all right? They always pull. And so how do you get the opposite action? Well, muscles work in antagonistic pairs. Antagonistic pairs allow for the opposite movement, so to speak. Most muscles work in antagonistic pairs, with one pulling a bone in one direction and another muscle pulling in the opposite direction. Muscles are known as antagonists. Usually have insertions on the opposing sides of the same joint. So here's your joint, this example here. You got your elbow joint, and you can see down here on either side of the joint, you have muscles inserting, but they're inserting on opposite sides of the joint. And so when they pull, this muscle will be pulling in this direction, flexing the forearm, opposed to these guys pulling on the opposite side of the fulcrum. You know what you call the fulcrum, like the, what do you say? Do you say seesaw or teeter-totter? You know, that thing on a playground? Another thing that goes like this. You sit on it and you go up in the air. You call it a teeter-totter or a seesaw? You call it a seesaw? That's a seesaw. What do you call it? A seesaw? Have you ever heard teeter-totter? You never heard of that word. That's what they used to call it when I was a kid, a teeter-totter. Let's go on the teeter-totter or seesaw. I'm like, seesaw? What's a seesaw? Looks like something you cut water with, a seesaw. You're cutting ice, a seesaw. A teeter-totter, because you're teetering. In a physics class, you talk about motion and force and that sort of thing. That what's in the middle of a seesaw or a teeter-totter is the fulcrum. And so you got force on either side of the fulcrum. That's what you got going on here. So this one pulls on this side, extends the forearm. This one pulls on this side, flexes the forearm. So they're the opposite movement. But the origins, basically in the same place, insertions are on different sides. See how it works? So muscles never push. They always pull. All right. Now, for muscle nomenclature, all right, muscle nomenclature, nomenclature of anything is the naming of something. And like I said, there's 656 named muscles. And I said it would be a rather dry course for me to just sit there and name 656 muscles and show you pictures of all them. Be crazy. And then I don't know. Some professors will do that, I guess. So I'm not going to just read them all. Just read them all and just learn them all. Not only you have to know the names of them, 656 names, know their origin, know their insertion, know their action, and know their innervation. The innervation is like the name of the nerve that goes to them. So 656 origin, insertion, action, innervation, and its name. That's 5 things. So what's 656 times 5? I don't know. It's a lot. And so that's how many things that you would have to study, for that. I don't do that in this class. I do that in another class though. And it's it's not fun. But it's how you learn, I guess. So rather than doing that in this class, to me, which is much more valuable, is understanding how muscles are named. And so you might not have never even seen a certain named muscle, but if you understand the nomenclature, you read the name, very often, just the name of that muscle will give you some insight about that muscle. Not always, but a lot of times. And so I want you to understand how muscles are named, and so you can gain some appreciation for their name. So nomenclature, background, is almost like a little history lesson here. I tell you, in the year 1895, going way back, a long time ago, in 1895, Latin was chosen as the official language for muscle nomenclature, that's true. Latin is chosen for the official language for almost everything in the biological sciences. Latin. Again, why did they do this? Well, this is, when I said that back in the day when you were being educated, you were taught in Latin. All right. So if you were, and that's what the church did. The church did everything in Latin. Even when I was a little kid, there was a thing called Vatican II. And the Vatican II in the church is when they changed and they supposedly modernized the Catholic Mass. That was in 1962, I think, is when it had happened. And then they said, okay, we want to make these changes in the church. And one of the changes that, okay, we're no longer going to say the Mass in Latin, because before 1962, when you went to church, the Mass was in Latin. So you had to sit there. If you didn't know Latin, you just kind of like, whatever. And the priest was facing away from the congregation, all kinds of things. But they changed things. But everything was Latin. Even when you went to college, you learned in Latin. Even I have some old anatomy books, and all the stuff's in Latin. Even when my dad was in school, a lot of the terminology was in Latin, like dexter and sinister instead of left and right, and so on and so forth. Anyway, so it just was chosen. But does anybody know why, of all the languages? I know the church used it, but why did the church use it, and why do they use it in science today? Does anybody know why Latin is used? Who speaks Latin besides priest? Does anybody? Is there like you go to a country, where do you live? I live in Latinville. You speak Latin? No, who speaks Latin? Nobody speaks Latin. No, that's the ancient Roman language, right? Nobody speaks Latin anymore. It's a dead language, right? So why on earth would you want to use a dead language in science? And name everything using Latin terms. Why would you do that? Anybody know? Dead language. What do dead languages do? Or what don't they do? They don't change. Because the English language, oh my gosh, look how fast the English language has changed, especially nowadays. Like every day there's like a new hip term, These kids talking, I don't understand what the hell they're saying. They're like saying things, words like back in my day, things were groovy and hip, far out, man. Nobody says that anymore. Right? What do you say now? Rad, I don't know. What do these terms? Woke, what the hell is that? I don't know what that means. You're woke? Or, well, I heard that there's on the radio, this guy kind of talks about hip terms. I don't know, but anyway, languages change. And so if you want some stability in your nomenclature, you want to use something that doesn't change. And it can be shared worldwide. So everybody understands. Like you name something, the Latin term, on this side of the planet, on the other side of the planet, they'll understand. Okay, so everybody's just one language that's not going to change. Latin. So anyway, we chose Latin. It was official. There was an International Anatomical Nomenclature Committee in England in 1895, and they said, okay, we're making the rules. This is it. Latin. We're going to use only Latin terms. And there's some other rules that were put into play on how to name muscles. Because before, a lot of times in science, they would just name things just willy-nilly, and sometimes they name it after their professors or institutions of learning or their wife or the best friend or, the color of the sky or whatever. No, they had to set some rules up. So, okay, here we go. These are the rules. Muscles are named according to several basic criteria, but there are certain criteria that we identify. The criterion, they are still related to a particular function or structure of the muscle being named. Okay, so it can't be can't use eponyms anymore. This is the Williams muscle. You can't do that. Each muscle name may include one or more different criteria. And you'll see, for example, there's 7 that they identify. 7 basic criteria. And this criteria are related to the muscle's location, remember body regions, where it's found in the body, okay? It could be its size, how relatively big or small it is compared to other muscles in the same body region, so to speak. Or the muscle, turn off my phone, sorry. Based on the shape of the muscle. Its geometric shape, maybe shaped like this, shaped like that, whatever. It could be named according to its fascicular orientation. Well, what does that mean? Well, remember fascicles, groups of muscle fibers. Remember that? Well, if you look at muscles, they have the fascicles all run in a particular direction. It's like the muscle has grain, you know, like a wood has grain to it. Like a, you can see the fibers in a piece of wood running one direction. The muscles the exact same way. And like you can cut meat, you know, across the grain or with the grain. You don't want to cut it with the grain because then it'll be too tough. But anyway, talk to a butcher how you got to cut up meat. Well, sometimes muscles are named to the fascicular orientation, the direction of the grain. And when you do this, the nomenclature is based on like a body's axis. Like you're parallel with the axis, you're perpendicular to the axis, and so on and so forth. Okay, so you see when we get to an example, I'll point that out. So, location, size, shape, fascicular orientation. Sometimes muscles are named according to their origin and insertion. Okay, and there's special rules we're going to see for if you're going to choose to name a muscle according to its origin and insertion. It's going to be a compound term. And the origin is always written first. And in the example, you'll see this. The origin would be like the prefix, and the insertion would be the suffix. Bam, you kind of make a compound term like that, okay? Sometimes muscles are named according to the number of heads they have. Heads? I didn't know muscles have heads. That's just another name for its origin. It's the head of a muscle is its origin, or you can call it its origin, its head. And so sometimes muscles have more than one origin. And so if you have a muscle that has multiple origins, you identify the number of origins, like 2 or 3 or 4, and a head, ceph, remember cephalic means head, ceph, like bicep or tricep, 2 heads, 3 heads, get it? Okay. And then finally, the 7th criterion that's used is, could be used, is the muscle's function or its action. When the muscle contracts, it's going to elicit some kind of motion or movement or whatever. And you can name the muscle after that. If it's flexing, extending, whatever, abducting, adducting, or just making some kind of action, you know, and you'll see that sometimes they're named after that. And so what I've done to share this with you, look, today, all these criteria, they're used. The names of the muscles today are the anglicized versions of the original Latin form. So they're not really Latin, but the English-fied, anglicized, that's what I'm talking about, the anglicized versions of the original Latin forms. And you'll see that, okay? So what I've done is I've built these tables for you guys to study from. Now, it's not all 656 muscles. I just kind of grabbed, in my mind, some good examples of muscles to demonstrate each of the criteria, all right? And so there's 4 columns. Here's a table with 4 columns. The first column is the criterion. You know, then you got location, size, et cetera, for all 7. You got the criterion, and then I give you a term that's based on that criterion, and I translate, you know, what it means literally, and then I give you an example, okay? And so this is how we'll go through some examples of muscles and see how they're named, okay? So on this table right here, all these examples these are all muscles. Of the 656 muscles, these are some examples. And all of them, however many are here, 2, 4, 6, 8, like, I don't know, 10 or 11 or 12 of them, they're all named at least in part by where they're found in the body, okay? And you can tell by looking at the terms, like pectoralis major, or pectoralis, pector, get it? Pector means, you think pectoral region, you think your chest. It means breastbone, so it's associated with your breastbone. And so when you look at pectoralis major, hey, it's named according to its location. Now this word right here, major, has nothing to do with its location. That's another criterion that we're going to see, okay? But at least this part is named according to its location. Second example here, same thing. Gluteus maximus. Gluteus, this word here it's a location because we know gluteus means buttock. You know, your gluteal region, gluteus, buttock, get it? So it's named according to its location because it's like in the butt region. Likewise, look at this word, brachia. Brachii means arm. Now, when we say brachii, I mean brachial. Remember, the brachial region is your upper arm. That's everything between your shoulder and your elbow. And there's actually a muscle there called the brachialis muscle. And so there's other muscles too, but that's what this one's just named after the upper arm. Okay, so this was, that would definitely be just a location. Look at the word pollicis. Pollicis means of the pullix. You remember your pullix is your thumb. And there's a muscle called the adductor pollicis. So again, this is one criterion. This is another criterion. This criterion is based on location. Okay, this is something different. We haven't got there yet. So this is a good example of that. Look at these next two words, supra and infra. Means above and below, right? Remember, superior, inferior, above and below your subject. There's a pair of muscles called the supraspinatus and infraspinatus, which literally means above the spine and below the spine. So what spine? What are you talking about? It's not very helpful, but you might not know where this is right off the bat. It's not too descriptive, but if you're studying the shoulder, what we're talking about here is the scapular spine. And so the word supraspinatus is referring to a fossa above the scapular spine. So supraspinatus is a muscle that occupies that space. And so, how is this muscle named? Well, the word supraspinatus is a location. Of the 7 criteria, what could this be? Well, it's location. It could be anything else, all right? So likewise, this one as well. Infraspinatus means below the spine. So there's that. I gotta move this thing here out of the way. Let me put it way up here. There. And then this, sub, means that's a location, right? Under something. And here, this word subscapularis, that's one of your muscles, the subscapularis muscle. What is it telling you, subscapularis? It means literally under the scapula. That would be a location, right? Where do you find this muscle? Well, you find it under the scapula. And if you look at the scapula, your shoulder blade, on the ventral surface of the scapula, there's a big depression called the subscapular fossa. And occupying that space is this muscle, the subscapularis muscle. Okay, so there you go. Buccal. You get buccal region, your cheek regions, and so cheek means cheek. Well, there's actually a muscle called the buccinator. Some people pronounce it buccinator. It's called buccinator. Buccinator muscle, cheek muscle. It forms the the walls of your oral cavity, I guess you can say. So that's a location, right? And the word psoas, the P is silent. It's not psoas, psoas. Which means loin. Your loin. What's a loin? Like tenderloins. You've heard of tenderloin, right? You're talking about steaks. You're talking about muscle. You're talking about meat, steaks. Okay, tenderloin or a pork loin. That's the lower back. It's real tender meat right there. And so psoas is in your lower back, and that's where your loin muscles are. There's a muscle called the psoas major. Now, you may never even heard of the psoas major before, but if you look at this, there's 2 criteria that are used. Here's psoas is one, major is another. What's psoas mean? Well, it means loin. That's a location. So you might not know anything about this muscle, but now at least you know where to look for it, right? So this is the lower back muscle. All right. So again, these are all named at least in part by their location. And this next example, or size. This is our second criterion, size. And so if you look at these terms right here, mini, maxi, major, minor, vastus, brevis, longus, semi, those are all based on size. And these are examples over here that use size. Like again, gluteus maximus, or I'm sorry, gluteus minimus. No, gluteus, that's a location. Minimus is a size, because mini, minimus, mini, get it, means smallest, okay? Opposed to maxi, greatest, gluteus maximus. So look at these two muscles. See how this is kind of falling together? Size and location. These muscles are named according to their location and their size. So gluteus maximus is the greatest, you know, of the two. It's the bigger one. It's your big butt muscle. And you have a little butt muscle. You actually have three butt muscles: gluteus maximus, gluteus medius, and gluteus intermedius. It's an intermediate size. I about didn't put it up here, but anyway, these two. So they're named according to their location and size. Here's a same thing, only different, just using some different verbiage. Major and minor means basically one's big, one's little. Major means greater, minor means smaller. And these two muscles, the exact same thing. Pectoralis major, pectoralis minor. Remember, pector means, you know, breastbone, chest. These are chest muscles, your big pectoral muscles, big chest muscles. Underneath them, there's a smaller version of the pectoralis major. It's called the pectoralis minor. And so these are both named according to their size and location. Okay, look at this word vastus, which means huge. There's a muscle, actually there's more than one muscle that uses the word vastus. Your anterior thigh muscles, which you call your quadricep muscles. There's three that use the word vastus. There's a vastus lateralis, a vastus medialis, and a vastus intermedius. Or vastus means huge, because your anterior thigh muscles, big thigh muscles. Now it tells you vastus lateralis, that's size and location, but lateral just means lateral. Doesn't tell you where in the body. Could be anywhere, right? Vastus lateralis. But when you're studying thigh muscles, that'll help you. So, oh yeah, lateralis, that's on the lateral thigh, and it's big. There you go, vastus lateralis. There's one on the inside, vastus medialis, and you'll see. You can like Google images all these and look at them, and hopefully it'll make sense to you. Okay. Brevis, like brief, something's not real long, it's short. Brevis, short, get it? Like adductor brevis. Now we didn't talk about this word yet, but we're going to see that that's an action. But adductor brevis, it's a brief, like short muscle, opposed to longus, which means long. So there's two muscles, adductor brevis, adductor longus. They're doing something. Adductor, we're going to see, is an action. So these are named, at least according to the size and action or function. These are thigh muscles that adduct your thigh. Well, we're going to talk about adduction, abduction when we talk about action. But anyway, for right now, these two are named according to at least their size. And then this, I threw this in here for funsies, semi or semi. It means like half. Like it's kind of half this, half that. There's two muscles that these are muscles that work together. You know, you got synergistic muscles that oppose one another, and then you got muscles that work together, like these two, the semitendinosus and semimembranosus. So it looks like one muscle, but it's actually two different muscles, and the semitendinosus is like sitting on top of the semimembranosus. Again, another thigh muscle. So like half and half. They kind of do the same thing, synergistic muscles as opposed to antagonistic muscles. Do the same thing. So there's that. And then let me scooch this thing out of the way again. Put it way down here. All right. I think it'll be out of the way. This table is defining shapes, or at least it's giving you examples of muscles that are named at least in part by what they look like, their shape, their geometric shape, or they're shaped like some kind of other structure, okay? For example, deltoid. Deltoid, remember we had lambdoidal, shaped like a lambda? That looks like an upside down V or an A without a cross piece. Well, if you got the upside down V, but then you close in the bottom of it, there's a capital delta. It looks like a big triangle. So something that is deltoid is shaped like the Greek letter delta, or looks like a big triangle, okay? You actually have a muscle called the deltoideus. Now, it doesn't tell you where it is, it doesn't tell you what it does, but it tells you what it looks like. And of course, if you're studying shoulder muscles, that's that triangular shoulder muscle on your humerus right there. So it's like a triangle, okay? Deltoideus. Or sometimes just people just call it the deltoid, and you know what you're talking about. Here's another geometric shape, a quadrate. What's a quadrate? It's a square. Quad, four-sided figure. It's quadrate. There's a muscle called the quadratus lumborum, okay? Look at this. Square muscle. What's lumborum mean, you think? That's, what do you think that is? What does it sound like? Lumborum, lumbar. What is your lumbar region? Your lower back. Yeah, in your lower back, there's a squarish shaped muscle called the quadratus lumborum. You know, look at it. But it's named according to its location, lumborum, and its shape, quadratus. Get it? All right. Gracile. Something gracile is like gracile. Thin and slender and delicate. You know, slender, gracile, slender. There's actually a muscle called the gracilis. Slender is a shape, I guess, right? Wouldn't be anything else. Now, slender muscle. It doesn't tell you where it is or anything, but again, if you look up the gracilis, you see it's a thin inner thigh muscle, thin little skinny strip on the inside of your thigh, gracilis, okay? Rhomboid. A rhomboid is like a rhombus. It's a rhombus. I have in parentheses diamond shaped. Like if you draw a diamond or something that looks like a diamond, like a, if you go to a geometry book and look up what a rhombus looks like, it'll tell you it's a uneven, unequal parallelogram. I think that's how they define it, a rhombus. Anyway, what does that mean? Well, draw a diamond, or I don't know. Because I know this because in other parts of biology, like in naming of species, the scientific names of things, excuse me, they use the word rhombus a lot because it means diamond, like the diamond-back water snake. Its scientific name is Nerodia rhombifera. Nerodia means water snake. Rhombifera means I have diamonds. Diamonds on his back because it's these little diamond-shaped patterns on his back. Well, anyway, look at this. Rhomboideus major. A rhombus, if you drew, I don't know if you remember in like a parallelogram, there's two lines that are parallel, and then the lines that go kind of like this, at an angle, uneven, unequal parallelogram. So that's what if you look at the rhomboideus muscles in your back, there's a major and there's a minor, but they extend between the shoulder blade and the vertebrae, and they kind of have that rhombus look to them. Anyway, just something to see. So it's named according to size and shape. Okay. This one, trapezoid. A trapezoid. You know what a trapezoid is? This is another weird kind of shaped thing. Trap. It's kind of, you draw a trapezoid, flat, angled. It's another four-sided thing, but it's, I have like shaped like an angle. or have arrow shaped, or chevrons. You know what a chevron is? A chevron is a four-sided figure with no two sides parallel. There you go. It kind of comes down like this and up like this. It looks like an arrowhead. And your trapezoid, there's a trapezius, it's a back muscle. It's going to shape like that. Okay. Teres. Teres, I have smooth. It's not a really good interpret. I guess smooth is a shape, but it's more cylindrical. The teres muscles are more shaped like a cylinder, like a smooth, polished cylinder. I guess that's where it comes from. There's a teres major and teres minor, so it's shape and size, right? Lati. Lat means flat. You have a big, wide, flat muscle on your back called the latissimus dorsi, dorsi for back. So that's a location and shape, right? Peri or piri, piri or pair means pear-like or a pear. And so if you look at the word piriformis, the suffix here, formous, literally means has the form of, or it's shaped like something. So piriformis means pear-shaped. And so, hey, piriformis, that would be, hey, it's named after its shape, right? Because it tells you right there in the name, piriformis, pear-shaped. There's a muscle that's kind of pear-shaped in your associated with your pelvic girdle. You'd have to look at that to see it. So it's named, of course, in the shape. Same thing here. Solia, soul means like fish, like fish shape. Can you draw like the little Jesus fish? You know, they have like on bumper stickers, that little, it looks like a figure eight, except you chop off the one half of the eight to make a tail. That shape, it's got a fish, is I call a soul or something is solia. And there's actually a muscle in your calf called the soleus. And you look at it, look at the whole thing, it kind of looks like a fish, shaped like a fish. See what a fish looks like. Splenium. A splenium is a bandage, like an ace bandage, you know, like it's like you wrap around, wrap, or like mummies are wrapped up in bandages. And there's some muscles that kind of give that appearance that look like they're bandaged, like little bandages. Splenius cervicus, like in your neck. So those long, strappy, kind of bandage-shaped muscles. And there's splenius cervicus and splenius capitis, both the neck, shoulder kind of stuff. The word serrate, to be serrated, that's a shape. It's jagged, like a serrated edge on a box of saran wrap or something like that. So something serrated is jagged or tooth-like. There's a serratus anterior. If you look at the lateral torso, there's these kind of jagged looking, serrated looking muscles on the side of the torso associated with the ribs. Serratus muscle. So serratus anterior, that's the shape, and anterior, that's location, right? And then gem. Gem means twin, like the like in what do you call it? Zodiac or astrology, Gemini. You know, the astrological, the constellation, the Gemini. Those are the twins, right? Pollux and Castor. Those are the names of the twins. Now the Pollux and Castor is not Pollux like Pollux the thumb. Pollux and Pollux, two different things. Anyway, those are the two twins. Anyway, there's a muscles called the superior and inferior gemellus muscles. They're twins because they're synergistic muscles. Again, these are some thigh muscles. Now look, I'm just now out of time in 5 seconds. And so today's Thursday. So Tuesday, oh my gosh, that shape. Well, yeah, I can't finish this. I'm gonna have to finish this Tuesday. That'd be perfect though. I'll finish this Tuesday. We'll be done. I'm not gonna take me an hour and 20 minutes to finish this Tuesday. So we'll finish early. We'll definitely have our test Thursday of next week, 1 week from today, which is what's the date? Today is the 25th. Tuesday's the 2nd. The 4th, that's March, right? March 4th will be your second exam. And so Tuesday, like I said, we're going to finish up this muscle nomenclature. I have plenty of time left over, so if you have any questions, think about that. We can. I don't really review. We can have a review. No, I don't do that. But if I have time for questions, it'd be kind of like a review. So whatever, we can do that. In the time we have left over Tuesday to answer some questions, go back over whatever you want to do. Just ask questions, whatever. But we can do that then. But if not, then that'll be it. So I'm going to cut you guys loose, and I will see you Tuesday, and have a good weekend. All right? You good? All right. Adios. Be good. And, if you can't be good at it.